Hello student, the question says a coil of n number of turns is wound tightly in the form of a spiral with inner and outer radii A and B respectively. When a current of strength I is passed through the coil, the magnetic field at its center is. Okay. Before solving this, you should know what is the magnetic field due to a coil. Suppose if you have a current carrying coil, a single coil, or let us take some n coils or something like that. So let us assume if I take n coils that are done in this way, what is the magnetic field at the center of the coil? So magnetic field at the center of the coil would be N times mu naught by 2R into I. This would be the magnetic field at the center of the coil. Then how do we solve this given problem? For this given problem, here, this is the given situation. We have coils arranged in this way. The inner radius is given as A, the outer radius is given as B, and the coils are arranged in this way, and we can say if this is A and this is B, this length would be equals to B minus C. Now to solve this problem, we only know magnetic field due to a single coil. Then how do we do this situation where they are curled in this way? To do this, let us take an imaginary area in this. So I will draw an imaginary area. Let us assume an imaginary circle. So at a distance from this, and I will take a slight thickness to that imaginary area. So I have taken a small imaginary circle here. Let us assume from here to here, the distance is x, and the thickness of this is dx. Okay, so at a distance x and the thickness is dx. The question says there are, if I ask you what is the magnetic field due to this, let us assume in this small dx thickness, n dash coils fit. So based on that, we can say the magnetic field due to only this small part, dB would be n dash into mu naught I divided by 2 into this distance is x. This would become the radius of this imaginary dx circle. Now the question is, what would be the value of this n dash? In the question, it is clearly given a coil of n number of turns. We have n turns. As you can see, we have n turns, the entire circle fitted in B minus A area. So in B minus A length, then we can simply write n dash equals to n by B minus A into dx length. The question is, how many coils would fit in this dx length? If n is proportional to B minus A, n dash would be proportional to dx. So else I'll do it here. N proportional to B minus A, n dash would be proportional to dx. Divide both of them, you will get this expression. Based on this, we'll get dB equals to n by B minus A into mu naught into capital I by 2 into dx by x. I want the total magnetic field. Since I want the total magnetic field, I will integrate the left side and I will integrate the right side. Now let me take it to the next page. So we got this as our result, and we can write the integration of magnetic field would be total B total would be whatever are the common, will bring it outside n by B minus A. Constants will bring it outside the integration. Integral dx by x. Integral dx by x is nothing but ln x. So n mu naught I by 2 into B minus A. This would become ln x. What's the least value of x possible? What is the largest value of x possible? If you see this carefully, the least value of x from where this entire coil starts is A. The largest value is B. So the limits are A to B. So if I solve it further, we will get B total equals to n mu naught I by 2 into B minus A ln B minus ln A. So we'll just get n mu naught I by 2 into B minus A ln b by a, I can write ln is nothing but log to the power base b by a, which is my option D. Hope you understood how I have solved. We have imagined, we have taken in these kind of questions where things are changing continuously. We have assumed a small strip, integrated it, and we got our answer. Thank you.